Scholars, welcome back. Starting off semester 2, we're going to talk about some polygons. What's poly mean? Many. Gon means side. So these are many sides. Sweet. What do we know about polygons? Well, they are formed by 3 or more segments called sides. Each side intersects exactly 2 other sides, one at each endpoint. So each side, like this side AE, intersects exactly 2 other sides, one at each endpoint. Each endpoint is called a what? Vertex. You're correct. And if we have many of these, we call them, the plural is vertices. Cool. You can name a polygon by listing its vertices consecutively. So this would be A, B, C, D, E, or E, D, C, B, A, or E, A, B, C, D. You get it. Okay. For instance, I could name the polygon above, like I just said. So let's look at example 1. State whether the figures are polygons. If they are not, explain why not. Is A a polygon? Will it have 3 or more sides? Yes. Does each side intersect exactly 2 other sides? Yes. How about B? Right off the bat, I want to say yes. It looks really familiar. We'll talk about that one soon. This is actually a parallelogram. It's definitely a polygon. C. 3 or more sides? Yeah, I mean, it's got 5 sides. Does each side intersect exactly 2 other sides? Yes. D. Is this a polygon? No. Why not? Because that part right here is not a segment. It's not part of a line. No. No curved sections of polygons. How about E? Well, it's got 3 sides, but each side doesn't intersect exactly 2 other sides. Namely, this side only intersects 1 side, and this side only intersects 1 side. So basically all of them have to be connected. No. Not all sides are connected. And F. Is this a polygon? Well, it's definitely got more than 3 sides. But in this case, some sides intersect more than 2 sides. Like this side here intersects 1, 2, 3, 4 sides. No dice. The segments can't cross, because then they intersect more than 2 sides. Cannot cross. Just how that is. All right, well, let's name some polygons that have certain numbers of sides. Like something that's got 3 sides, what do we call it? A triangle. Very good, very good. How about something that has 4 sides? No, it's not a square. It's not a rectangle. Anything with 4 sides is called a quad. For 4, quadrilateral. Remember, lat means side, so 4 sides. 5 sides is a pentagon, like the one that we have for our defense building. 6 sides is a hexagon. 7 sides is a heptagon. 8 sides is a octagon. Octagon, like our stop signs. 9 sides is a non-agon. 10 sides is a decagon. Dec meaning 10. We just entered another decade, another 10 years. 12 sides is a dodecagon. Whoops, not dodeg. Dodecagon. And these are the only polygons that get specific names. If they have any other different number of sides, it's called, like something that has 11 sides would be called an 11gon. Or 13 sides would be a 13gon. So for n sides, meaning a different number of sides than what is represented here in any other number, it would be called an n-gon. All right, cool. We have special kinds of polygons, namely equilateral polygons. I bet you know what this means because we talked about equilateral triangles, right? So an equilateral means equal sides, a polygon with all sides congruent. An equiangular polygon, equal angles, a polygon with all angles congruent. What's congruent mean again? Has the same measure. Very good. And a regular polygon is a polygon that is equilateral and equiangular. All right. You're doing great, guys. It's your first lesson back. Nicely done. So let's look at this example and decide whether the polygon is regular. What did regular mean again? It meant equal sides and equal angles. Well, this guy has 5 sides and they are all equal. How do we know? Because each of them have the same number of hash marks. And so let's check out the angles. We definitely know it's equilateral. We've got 2 right triangles, we know because of the squares in the corner, but these aren't marked as right triangles, so it's not equiangular. Not equiangular. So, no, it's not regular. Okay, well, let's look at B. This has 1, 2, 3, 4 sides, so it's a quadrilateral. I see that all of the angles are right angles, but I see the sides are not all the same length. These have 1 hash mark, these have 2. So this is equiangular, but not equilateral. So no, this is not regular. This is a rectangle, which we'll talk about soon. All right, we got another way to talk about polygons. They're diagonals. So a diagonal is a segment that joins 2 non-adjacent vertices. Non-adjacent vertices. Okay, so let's, in example 1 here, check out this polygon and find some diagonals. Remember, what does non-adjacent mean? It means not right next to each other. So, some non-adjacent vertices here. B and A, are those adjacent to each other? Yeah, they're right next to each other. But B and F, those are not adjacent. So there's a diagonal. All right, let's try to draw all of them. What I would recommend is start at 1 vertex and draw all the diagonals you can, and then move to the next one. So let's start with B. We got 1 here. We got, I'm going to move my paper over so I got some space. 1, 2, maybe I'll label these as I draw them. 1, 2, 3. Look at that nice straight line. Can I draw one from B to C? No, because C is adjacent to B. It's right next to it. So I've got 3 there, 4, 5, 6. Can't draw one from C to D. D already has one to B. D needs one to A, would be 7, and F would be 8. E has one from E to C, E to B, so I only need one more here to make 9. And F has all. Huh, all right. How many do each one of them have? Looks like 3. diagonals go with each vertex. So we have 9 diagonals. Cool, cool, cool beans. All right, we talked about interior angles of a triangle. Do you remember how many angles or how many degrees were in a triangle? It was 180, that's correct. So how many degrees will be in a quadrilateral? It's going to be 360 degrees, and let me show you why. If I took this quadrilateral and I chopped it into I can chop it into 2 triangles. So I've got 180 degrees here and 180 degrees here. So these 2 angles together make up one of the angles of this quadrilateral, and these 2 angles here make up another angle. So this 180 degrees plus this 180 degrees makes the 360 degrees of a quadrilateral. So let's use that factoid for our next example and find the measure of angle F, the measure of angle G, and the measure of angle H. What are they all going to add up to? What did we just say? The sum of the measures of the interior angles of a quadrilateral was 360 degrees. So all these guys, 55 degrees plus X plus, well, I don't know what G is. The measure of angle G plus X equals 360 degrees. Well, wait, we do know what G is. G and E have the same number of arc marks, so that means they're exactly the same measure. So this is actually 55 degrees. So we've got 55 degrees plus X plus 55 degrees plus X equals 360 degrees. So this simplifies to equals 55 plus 55. 110 plus 2x equals 360 degrees. All right, let's get that x by itself. Oops, not 100, 110. So let's minus 110 on both sides, and we get 2x equals 250 divided by 2. So what's x going to equal? Oh, you can't see that can work here. X is going to equal 125. So that means these guys are each 125 degrees. And we found all the measures of the quadrilateral. Now this is a really special one, which we'll talk about soon, where opposite angles are congruent to each other. And consecutive angles here, 55, what would we get if we added 55 plus 125? Oh, we'd get 180 degrees. They're supplementary. So this, again, we'll learn about in a minute, is a parallelogram. Cool. All right. We got 2 more examples. So let's find the measure of K, L, and M and decide whether this quadrilateral is regular. Well, it's off to a good start because I see that it is equilateral. We just got to prove, hopefully, that all of these add up to 360. So let's see what we get. X plus X minus 20 plus X plus 80 equals 360. So if we simplify, we've got x and x and x, we've got 3x. And a negative 20 plus 80, that means that's 60, is 360. Let's subtract 60 on both sides, and we get 3x equals 300. Divide everybody by 3, x equals 100. So we've got these 2 angles that are 100 degrees. This one is 100 minus 20, so that's 80 degrees. Is this regular? No, it's not equiangular. It's not equiangular. Sorry. All right, finally, example number 3, we're going to get cut off. So this is going to be part of your job to finish this example. Use this information in the diagram to solve for x. So how many sides does it have? 1, 2, 3, 4. So all of the angles inside should add up to how much? 180. So add all of these up for 180 and solve.